Good morning everyone. This is exercise 14.2 and the first question is which of the following figure have rotational symmetry of order more than one. So as I told you, the rotational symmetry order we can find when a figure moves a complete turn and it again get the same image or same position at it is in the beginning of the rotation. So all the figures A, B, D, E and F. These figures are having rotational symmetry with order more than 1. In the second question, we are having give the order of rotational symmetry for each figure. So if for first figure, we can see if this is the point M, if this is the point M, so first if we rotate it once 180 degree, then the point M will be here, and again if we rotate it 180 degree, then the point M will be here. And as in the beginning we can see that we mark it as point M, so we again get the same image. That means the order of rotational symmetry is 2, and we are also having two rotational figure for this diagram. In the second part, B question, in second question we are having a cross, or we can say a X, which is having 80 degree angle, and firstly we have to rotate it 180 degree, and then again for second time we have to rotate it 180 degrees. If the T diagram if the point T is at this place, if the point T is at this place, so if we rotate it once it will become at the extreme upper left corner, and if we rotate it once more at 180 degrees it will come at the lower extreme right corner. So the rotation order of rotational symmetry is 2. As you already know that in an equilateral triangle has order of symmetry 3, and an fan which is having 4 lines, or we can say 4 sides, so it is also having order of rotation symmetry 4. And in the last diagram, that is E part, it is having order of rotational symmetry 4, and in the pentagon we have order of rotational symmetry 5 because it is a regular pentagon. And in the last G part, in the next G part, we are having a star, and this star having 6 lines of symmetry. It is also having 6 order of rotational symmetry. And in the H part, it is having it looks like a equilateral triangle, so it is having approximately 120 degree angle on which it will rotate, and that's why it will show you the order of symmetry of 3. Now moving on to the next exercise 14.3, the first question is name any two figures that have both the symmetry and rotational symmetry. So these two figures are circle and square. Circle and square both are having both lines of symmetry, that is horizontal and vertical, and both are also having rotational symmetry. It is having rotational symmetry of 90 degree, and it is having rotational symmetry of a complete turn, that is 360 degree. Now moving on to the next part is draw wherever possible a rough sketch of question first a triangle with both line and rotational symmetry of order more than 1. एक ऐसा triangle you have आपको draw करना है in which we have both line and rotational symmetry, जिसमें line symmetry भी हो और rotational symmetry भी हो. Line symmetry means if you draw a triangle, equilateral triangle, and if you draw it like this, so first, second and third, so we are having 3 lines of symmetry in equilateral triangle, and also order of symmetry of equilateral triangle is 3. So that's why we have symmetries of order more than 1. इसका मतलब हमें इसमें number of order of symmetry कितना है, 3 है, जो कि 1 से ज़्यादा है. ऐसे ही in the second part, an isosceles triangle. So an isosceles triangle is having two equal sides in which we have one line of symmetry, and also the rotational symmetry for this is 360 degree, and in a 360 degree it will take only one turn. Rotational symmetry वो symmetry है in which we will again get the same image as it is in the beginning of the rotation. Third part, a quadrilateral with a rotational symmetry of order more than 1 but not a line of symmetry. So it is not possible to get rotational symmetry if there is no line of symmetry in any shape. Fourth question, a quadrilateral with line symmetry but not a rotational symmetry of order more than 1. So a trapezium has equal and non-parallel sides, a quadrilateral with line symmetry but not a rotational symmetry. So in a trapezium is this which is having two parallel lines and two non-parallel lines. So if we cut it vertically, then we can get one line of symmetry. We cannot cut it horizontally, so we will make line of symmetry only vertical line of symmetry. So a trapezium is having only vertical line of symmetry, and if we rotate it 360 degree, that means a complete turn. It means it is only having one rotational symmetry. Next question is, in a figure has two or more line of symmetry, should it have rotational symmetry or of order more than 1? So yes, because every line through the center from a line of symmetry has its rotational symmetry around the center of every angle. अगर किसी भी फिगर में दो से ज़्यादा लाइन्स ऑफ सिमेट्री हैं, दैट मीन्स यस इट इज़ ऑल्सो हैविंग रोटेशनल सिमेट्री मोर देन 1. अब जैसे हम अगर एक इक्विलेटरल की बात करें, सो इट इज़ हैविंग 3 लाइन्स ऑफ सिमेट्री एंड इट इज़ ऑल्सो हैविंग ऑर्डर ऑफ सिमेट्री 3. हम अगर स्क्वायर की बात करें, सो इफ इट इज़ हैविंग 4 लाइन्स ऑफ सिमेट्री, सो वी हैव ऑर्डर ऑफ सिमेट्री रोटेशनल सिमेट्री इज़ 4. सो इट मीन्स अगर किसी भी शेप में लाइन्स ऑफ सिमेट्री 2 से ज़्यादा हैं, तो उसका ऑर्डर ऑफ सिमेट्री भी 1 से ज़्यादा होगा. ऑर्डर ऑफ रोटेशनल सिमेट्री भी 1 से ज़्यादा होगा. नेक्स्ट फोर्थ क्वेश्चन इज, वी हैव टू राइट द सेंटर ऑफ रोटेशन, ऑर्डर ऑफ रोटेशन एंड एंगल ऑफ रोटेशन. सो फॉर ए स्क्वायर, सेंटर ऑफ रोटेशन इज द इंटरसेक्टिंग पॉइंट्स ऑफ द डायगोनल, ऑर्डर ऑफ रोटेशन इज 4 एंड द एंगल ऑफ रोटेशन इज 90. मैंने आपको बताया था एज आई टोल्ड यू अर्लियर दैट ए स्क्वायर हैज़ rotational symmetry at every 90 degree rotation. A rectangle has intersecting points of or we can say center of rotation at intersecting points of diagonals. It is having order of rotation 2 and angle of rotation is 180 degree. Again, rhombus, it is having intersecting point on diagonals. Rotation of symmetry is 2 and angle of rotation is 180 degrees. For equilateral triangle, as you know very well that it is having intersecting points of medians. ये जो हम intersecting ये जो हम line of symmetry draw करते हैं, these are also known as the median of any triangle, equilateral triangle. So it is having order of rotation 3 and the angle of rotation is 120. In a regular hexagon we have order of rotation 6 and angle of rotation 60 degree. In a circle we have order of rotation infinite and angle of rotation at every point. अगर आप सर्किल को 1 डिग्री भी मूव करते हैं, सो इट विल अगेन शो यू द सेम सर्किल. Next is semicircle. So the midpoint of the diameter is the center of rotation and order of rotation is 1, that is angle of rotation is 360 degrees. मतलब अगर आप semicircle को 360 डिग्री मूव करते हैं तभी आप उसका सेम ऑर्डर देख पाएंगे, सेम पोजीशन देख पाएंगे. नेक्स्ट, नेम द क्वाड्रिलेटरल विच हैव बोथ लाइन ऑफ सिमेट्री एंड रोटेशनल सिमेट्री ऑर्डर मोर देन 1. सो इट इज़ ओनली वन, that is a square. Its square is having both lines of symmetry, that is horizontal and vertical, and order of symmetry is more than 1, that is 4. Okay, Next is after rotating by 60 degree about a center, a figure looks exactly the same as its original position. At what other angle will it happen for the figure? So for this figure, it in this figure it is showing that 60 degree, at every 60 degree it will happen. So it will also be can happen at 120 degrees, at 180 degrees, and at 240, 300 and 360. Means if we rotate in, if we starting from this point, so if we take 60 degree, so at every 60 degree the figure will be same, but if we find out the order of rotation, then it will have to rotate 6 times for 60 degree. So this will show that the order of rotation is 6 for 60 degree angle. If we take 120 degree angle for the same image, so at every 120 degree angle the image will show the same image. But if we talk about order of symmetry, then it will have to rotate 3 times for getting the same position as it is at the first time, 120, 120 and then 120. So order of symmetry हम कैसे निकालते हैं? When we get the same image as it is in the earlier of the rotation. रोटेशन शुरू होने से पहले जैसी हमें इमेज होती है, रोटेशन 360 डिग्री के रोटेशन के बाद भी अगर हमें वैसी ही इमेज मिलती है, क्योंकि देखिए अगर हम इसको 3 टाइम्स मूव करते हैं तो अगेन देखिए डायग्राम के अकॉर्डिंग आपको पी पॉइंट यहाँ पर मिलेगा आफ्टर दैट रोटेशन। तो देखिए 120 120 120 विल गिव यू 360, है ना। सो अगेन फॉर 180 वी कैन सी दैट इफ़ वी रोटेट इट 2 टाइम्स, when you rotate it one time it will be here, and when you rotate it another time it will be here. So again we get the same image after 2 rotations, that means it will rotate 2 times. So every time as the angle of rotation increases, the number of order of symmetry will decreases. So for 360 degree rotation we have only one order of symmetry, for 180 we have 2 order of symmetry, for 120 degrees we have 3 order of symmetries. Next, 7th question, can we have a rotational symmetry of order more than 1 whose angle of rotation is 45? So if the angle of rotation is 45, then the symmetry of order is possible and would be 8 rotations. And the next is 17 degree. If the angle of rotation is 17 degree, then the symmetry of order is not possible because 360 degree is not completely divided by 17. That means if you have to find out the order of symmetry, that particular given angle must be completely divide the 360 degree angle so that we can get the order of symmetry. Thank you.